Hi everyone again. As Moritz says, we will first have a brief look at CALPHAD Optimizer 2.1, which is the current release version that is available to all FactSage users. And before even I show that, just a reminder, in FactSage, once you install FactSage, you have everything running on your computer. By default, CALPHAD Optimizer is not there, but you have access to it. So if you start FactSage, you click on CALPHAD Optimizer here on the bottom, and then you'll be given two options, OptiSage or CALPHAD. The second option, CALPHAD, means opening this new programs. But if you haven't installed it yet, once you click on CALPHAD here, it will show you a link or give you the URL address to this page that I have open here in the back. So just so you know, if you are interested and you have FactSage, you can already try it right now. And just follow the instructions in the website and things should work out. Then on my side, I will open CALPHAD Optimizer from here. I have something out. Yeah, okay. And that's how we open it. It's already running. I have it. So sorry. Don't want to cause any issues. Yeah, seems to be fine. It's just because I have the development version running at the same time, but that shouldn't be a problem. Then when you start, I mean, it has been under development for quite some time. We are very proud of this product because I suffered quite a lot. I mean, we just heard Reis's talk about database development, and he mentioned the PCM2 project. I started working at GTT on PCM1 in the database development of salts. And at that time, about, I don't know, already 6-7 years ago, maybe even more.
Yeah, 7.
Yeah.
8.
8, yeah, a long time. It was, we didn't have CALPHAD Optimizer, and it was quite tricky to make things work when we wanted to optimize databases. So all of that amazing work you just saw was mostly done by hand, and some people even still do it, right, Elena and Tanya? I don't know how, I still don't know how, but they do it. I really couldn't, so I wanted to have a tool that could help me in this process, and it all felt like it was completely possible to do it. So. But then we invested a lot in the last years, and now we are already in version 2.1. And this is how it looks when you get started. So it is split into the different stages of the assessment that normally we have to go over. The first stage is to load a database. So we don't show it here, and you cannot really create a database at this point. Not yet, but maybe soon.
Not yet in CALPHAD Optimizer. I mean, of course, you can create in FactSage.
Exactly.
But then you have to export to chemsage.int. But we don't want to talk about that. That's not the nice part, right?
No, that's not the fun.
We hide that.
No. And you already learned how to do that. Moritz showed that, right?
Yeah.
So what we want and what you can do now is to simply load that database that was generated from FactSage itself. And normally when you do this, you click on load database and you have to go over your files, and you are given the option here to load a .dat file. A .dat file is the same as the CST file, but it is the open format where you can see all the contents of the database, you can edit, you can work with it, and you know all the thermodynamic parameters in there. So that's how we normally load a database. I'll just load here the example for Latin-10. This is the standard example that comes with the program. We have a few examples. And the next part is then to set up your experimental data. So you either have them from the literature, or as Reis also showed, if you work in Jülich, you are, you have so many tools there, so many toys to play with, and you can generate your own experiments. And then once you click on experimental data, you would go over new group, add the group name, for example, liquidus temperature. And then you expand on this new group. And then by default, you always have to select the experiment type. By default, the first one selected is the liquidus temperature. But you have some other options here that facilitate a lot the input of experimental conditions. So you also have solidus temperature, the two-phase equilibrium recipe, which is a very rich one, very powerful recipe to calculate two-phase equilibrium, basically phase equilibrium data. Then also the heat of mixing, heat of reaction, entropy increment, and anything else that you don't have here on this 6 top ones, you can set up with the user-defined recipe. And then basically taking the liquidus temperature as an example, you can see here that it is quite straightforward, right? You have the input fields, they are self-explanatory, and you just need to inform the conditions for your experiment, the liquid phase for this system, because the liquid sometimes it's not called liquid. You have to inform the program what it is. And then the components, if you have more than one, at least 2 for an assessment, right? You can inform here. You can select your database, your phases actually from your database. And then you enter the input for the actual concentration and the target temperature. Once all of this is done, you can click on test and you can see results, at least to check at this point from the starting point of the database, if the setup is correct and everything is as expected. The next part is to open the parameters and select the parameters for the optimization. When we expand them here, you can click on either the pure compounds, any of them that are available in the database are available here. And you have all the standard properties for the pure compounds. So heat of formation, entropy at 298, and the heat capacity with all the different temperature ranges and the different coefficients for each range. Below this, you also have a quick plot. You don't see much. You cannot change that plot very much, but at least it's a quick plot to see if there's anything strange with the standard properties of this particular compound. Sometimes you see amazing things here. And for the functions, databases with functions, you can see them here. The standard properties are defined in the same way as for the compounds. So again, HSCP. But the fun part is actually in the solutions field here. You can expand on any of the solutions to check the contents for the end members, what end members you have. And depending on the definition of that end member, you can also select here for optimization the prefactors for the Gibbs energy function that is composed of sometimes more than one function. In this case, PB is composed of only PB function 1. So that's not so much fun. But sometimes you have 2 or 3, and then you can select and optimize even the distribution from the contribution from different functions. Then this is the hot topic, the interactions. When you click on one of them, they should be already at least created from the solution module. You cannot create at the moment, but not for so long, I think. Then if you have created them, they are here. And you can select directly from this view the coefficients for the optimization. So you can also see a short description of what interaction type this is, binary Bragg-Williams-Radich-Kister. This is the L0 interaction parameter. And then you can select normally the temperature independent term and the temperature dependent term. And then you see when I click on them, they automatically are given a name. And if I scroll down and now I open the optimization block.
Do you want to maybe load an op file and then?
Yeah, that would be a bit more fun, but I like to start from scratch. It's always much more fun.
Oh, come on.
Yeah. Okay, I can do that, Moritz.
To go for an op file.
Yeah, okay.
We practiced for hours.
Exactly. And we couldn't figure out these parts before. But sure, it would be a bit more descriptive. So you can also load a previously saved opt file, which contains all of this setup that we were going over now. If you click on File, Load Optimization, and this one is already given here. I click on Opt. It loads database, experiments, parameters. And then if I now expand on optimization, I see all the selected parameters. Here we have L0A of the liquid phase, L0B, which is now listed here, but not at this point selected for optimization. And same goes for the BCT phase and for the FCC phase. And here on the top, you can also see all the different experiments that were generated for this particular assessment. Tie line, metastable FCC, immiscibility gap, liquidus, and solidus. This is a simplified case. If you are interested in a complete assessment of this particular system, we have even published this recently. We are very proud of it. And you can find it in the CALPHAD journal. We show it here, the latest developments specifically for the 2.1 version, where we made a huge progress on the description of the error function. And I'll just show this very briefly. Before you can see how things worked. I will not go over all the details, but I just want to point out that if you look at the plots on the left side here, you can see a lot of blank spots. And these blank spots would cause optimizations to fail, or at least to be very slow and very inefficient. We changed many things in the calculation of the experimental data in the background, right? In the recipes of the experimental data, so that, I'm sorry, the error function now behaves much more smoothly, and it has a global minimum in most cases that is much, much more easy to find. And then you can see here that it has a minimum, in this case, right in the middle of the two interaction parameter ranges. And that's why this is such a great advancement for the latest version that is available. Please have a look. And you can also see, as I mentioned, the full database for the full description of experiments for the lead-in-tin case, and everything is discussed there. But now,
how long does such an optimization run?
Uh,
do this even live? Could you click on run here?
Absolutely.
Run live?
Yeah. So once everything is set up and selected, you can simply click on optimize with the default settings for the optimizer. And we can check. I don't even remember how long it takes for this one.
I think 1 minute, 20 seconds.
Oh, are you sure?
I don't know.
And you see one of the great features also of CALPHAD Optimizer is that you get to see live the updates for the interaction parameters and the resulting calculated experiments. So the comparison is directly given here. That was even faster, 25 seconds, you see. Now we already have a very good fit for the phase boundaries. And this is about it. Anything to add for this point? I don't remember.
No, this looks fascinating.
I think so too.
Yeah. Okay. But now what do I do if I want to add a new parameter to the database?
Yeah, in this case, you would need to go back to FactSage.
Okay.
Open the solution model. Probably before that, you need to import what you just created here, right? You need to save this database as a .dat file here on the top.
Yeah.
Save as a .dat. Add a new interaction parameter.
Who invented that workflow? Okay,
someone a long time ago.
Let's change that.
Let's change that. Okay.
Okay.
So we are in the process of changing this, and we are very happy to be able to do this now with a lot of help from our colleague Florian. We have added quite a lot into the stuff, but I'm not sure of ChemMap for even ChemMap itself in a way. Not even ChemMap for Python. It will be available for ChemMap for Python as well. As I mentioned yesterday, also we are changing the backend to make use of the Rust programming language, which is a lot more robust than Python itself. And it has allowed Florian to create the XML database format, as he demonstrated in the first day of the users meeting. Now I'll show you how this looks, because we are integrating all of that with CALPHAD Optimizer. And I have here the development version of CALPHAD Optimizer open. Yes, this runs in a browser because we use JavaScript to create the front end. And in the development version, that's how I work with it. And you can directly see in this new version, two little buttons here that are now different from what we had before. Before we had save database, and now we have save .dat or save XML. We will still decide exactly how this will appear for you guys in the final version, but the most important thing is the functionality here to actually save databases as XML and also to load them as XML. So if I click now on load database, you see here, I have DATs, but I also have support for XML format, which is the XML format. So I'll just load a .dat file to get started, as we did before. There is one constraint at the moment in the development version that we will be addressing very shortly, which is we don't support that files with functions. If you export things from FactSage, you might know what I'm talking about. If you haven't done it yet, don't worry, it won't affect you because when this is released, this will be solved. But at the moment, I'll just load the case for crumb and nickel without functions and as a .dat file first, just to show you that, yeah, we have an interaction. So if I add an interaction here for the liquid phase, let's say A equal 10 of the L0 parameter, I can save this database now, again, as always, as a .dat file, but finally, I can save it as an XML as well. I have already a few versions from the tests, but let me just add this as the demo version. And this is the fun part. Where can I open it best? Over here. Demo. You get to see now, not here, because this is too crowded. I need to first get out of the full screen, just a second. And I have the second Visual Studio window. And you can see many interesting things here. This is the new XML format, or the ThermML. And one nice feature about VS Code and good text editors is that you can group things, different categories, like I'm doing it right now. Otherwise, you see too many things at the same time. But because this is a very well-structured database format, you can go over it very clearly over the different groups of the hierarchy that are defined here. So if we expand on database, you clearly see that there are system components, phases, functions, depending on the case. And if I go to phases, I can see all the existing phases in this database with clear names, clear fields for all the names. And I can expand, for example, on the FCC phase 1 here, FCC A1 phase. I have, again, the end members, and the interaction is here as well as a list. And I can expand or let me check, on the L parameter here. I have the L parameter L0 and L1. I'll just add something here, you see. And to me, this is amazing because I have been working with databases for a long time, and I couldn't really make sense of that file. Sorry, GTT. But I always appreciated the fact that there was an open format for the databases, of course. But it is a bit tricky because it has many internal key phrases or key words that you need to get used to. And I was never so comfortable changing things there. But if I changed it now, I feel quite safe because I have all the highlights, all the things. I love very different colors in my editor, so I know what I'm doing. And so, for example, if I just want to add one parameter here, or actually to change one of the parameters, I can just change it, I don't know, 50, might be too much, L0 of the FCC phase. And that's it. I can click on Save, and I can rely that this database is safely created or stored in this way. So to confirm this, now with the new version of CALPHAD Optimizer, I can just create a new optimization to release everything else. And I'll load the database that I have just changed manually, which was the demo one. And I can go over to the parameters section, list the interactions of the FCC phase, L01, and you see my 50 coefficient. Thank you.
Could you even add a parameter?
You could, but then that's a bit more advanced for me. I'm quite sure that Florian could do this live. Are you interested in Flo?
Let's do this live. Shouldn't you be able to do this live?
Sure, we totally practice for this, right, Moritz?
No, we didn't practice at all. So
yeah.
Maybe.
You want to add what?
Rank 2.
Rank 2.
Yeah,
I can
L2.
Expression should be okay. I'll just copy that one.
That would be the sensible way.
Yeah, sure.
Enable this, right?
Absolutely.
So I guess.
So we have just created, we had L0, L1, we have just created L2 with the rank 2 interaction for the FCC phase. I'll just again click on Load Database. Load the demo. FCC, interactions, and the L2 phase is here.
That was fast.
That was quite convenient. I'm also surprised.
Did the graph, or is it just for looking nice?
No, that's a true graph. If you change the values here.
Sorry,
this is the excess contribution from this particular rank of the interaction parameter. So this is the L2 contribution. As far as I know, I think it could work for all the excess parameters for the...
Good question.
Okay. That's good to know.
Yeah.
We'll check on that.
I guess. Yeah.
I mean, yeah, it's very good that you mentioned.
Thank you.
Yeah. We can check.
Yep.
We can double check.
Okay. So for the online audience, that was just a bug report that we don't want to discuss any further. Yeah. No. It's a bug. Okay.
Yep. I think that's about it. I mean, what I can show you now is we changed the database a bit, where I had a previously selected set of parameters. I think it should work because it is a subset of the current selected one or current one available, which is from the paper where we optimize the Chromium ecosystem. You can see it's also here. Everything else but the L2 because it's not needed there. I'll just make this L2 0 because it would affect the optimization otherwise. And I'm missing the experimental data. What I will demonstrate now is a simple optimization now when we actually started everything with an XML file. So liquidus and solidus to make things quicker. Phase equilibrium for Chromium eco case. Selected parameters are here. Liquid FCC. Let me check. Something is strange. Yeah, okay, it selected the L2. Yeah, I was too optimistic that it would understand everything, but it's okay because it's not selected. It's just because we, because we changed it, so it automatically appears here to remind us that this database has been altered. But it should work. So now if I just click on Optimize again, and I expand on the results, we can see for each experimental group, I was a bit too fast on the first demonstration, but you see for each experimental group the plots, and you always get also one plot that combines all phase equilibrium, which is called the phase boundaries plot, and which resembles a lot a phase diagram, but in this case, it would be a very simple one because we only have liquidus and solidus data. And you can see it is optimizing from a XML file. It is quite convenient, and we are almost done with the implementation work.
Yeah, and maybe just one comment. Why does the implementation work take so long? Because the flow has to define all of the database formats in the XML structure. And because there are so many thermochemical models, we need to cover at least the most important ones. This is taking a bit of time.
Yeah.
And it is open. So if you want to contribute to that, dear community, Flo already shared the link to his GitHub account with the ThermML. So I guess even Googling ThermML and Florian Tang might help if you're lucky. Yeah. Yes. Okay. Thank you very much, Bruno.
Thank you.